Hello friends, welcome back. Today in this video we will be interfacing a new analog to digital converter which is MCP3427. For more info about this sensor, let's go to controleverything.com and here search for MCP3427. Here is our sensor. It is a 16-bit 2-channel analog to digital converter and some of its more features are mentioned here. You can also purchase this sensor from here. Today in this video, we'll be interfacing this sensor with a Raspberry Pi and a Java code. For that, click on Resource tab and here you will find the code sample in different platforms. Click on Java code sample and you can download all the codes from here as a zip file. Or else, you can download all the codes from our GitHub repository which is Control Everything community. In hardware connections part, first thing we need is a Raspberry Pi. And these are the GPIO pins of a Raspberry Pi. Now this is an I2C Shield. The Shield is available on controleverything.com and you can purchase it from there. The reason behind using this is to make connections with other I2C devices easy. So gently place this over the GPIO pins and make a connection like this. Now to power up a Pi, we need a micro USB cable and gently insert this in the power jack of the Pi. To provide an internet connection to the Pi, we have two options. Firstly, we can use the Ethernet or LAN cable like this and insert it in the Ethernet jack of the Pi. The second option is a wireless nano USB adapter and insert this in the USB jack of the Pi. You can choose either of the options, the choice is yours. This is our sensor MCP3427 and this here is a connecting cable. Connect the sensor with connecting cable like this and while making connections, please make sure brown wire of the cable should be connected to the ground of the sensor. And the same rule applies to the I2C Shield. With this, we are done with the hardware part. Now let's move to the interfacing and working of the sensor. For the interfacing of the sensor, first of all, we have to log in github.com. And here we have to search for the repository which is Control Everything Community. Now here search for our sensor MCP3427. Here is our sensor. And this is a Java code. But first, let's go to the instructions we have to follow. We have to download and install the Pi4j library on our Raspberry Pi. And steps to install Pi4j library are given in this link. Please go through this link, note down all the relevant steps and install the library very carefully. After that, this is the command for compilation of the Java program and this is the command to run the Java program. Now let's get back to the code. This is our Java code with .java extension. Click on it. And here is the Java code. First of all, we have included some of the Pi4j libraries here and we have created the public class of MCP3427 here. Later on, we have to get the I2C device address of MCP3427 which is 0x68 and we have done that part here. In the writing part, we have sent configuration command 0x010 in which we have selected continuous conversion mode, channel 1 and 12-bit of resolution. After that, we have given a delay of 500 milliseconds here. In the reading section, we have to read 2 bytes of data which is raw ADC MSB and raw ADC LSB through the register 0x00. After that, we have to convert the data to 12 bits according to the formula given in the datasheet of the MCP3427. Finally, we have to output the data to screen with this command. And with this, we are done with the interfacing of the sensor. Let's move to the working and see how it performs. For the working of the sensor, first of all, we need to copy the entire Java code. And then we have to open the terminal. Here we have to create a new file with name MCP3427 and then we have to save the file. Now we have to compile our Java code with the command given in the instructions. It will take a while. Now our Java code is compiled. Now we have to run our Java code. As you can see, the initial output is 0 because there is nothing connected to the channel 1 of the sensor. But when I connect a 1.5 volt of a battery cell to the channel 1, then you can see the output is now 1315. On again running the code, it is 1316. It is almost constant because the cell is connected continuously. So this is how the code works. Now let's move to the application features of this sensor. The sensor is a 16-bit analog to digital converter with differential inputs. It is a low noise and high accuracy 16-bit delta sigma analog to digital converter. It is the family member of MCP3427 series from the microchip technology. The device can output analog to digital conversion results at rate of 15, 60 or 240 samples per second depending on the user controllable configuration bit settings. The device have two conversion modes, one-shot conversion mode and continuous conversion mode. The application includes portable instrumentation and consumer goods, temperature sensing with RTD and thermocouple, bridge sensing for pressure, strain and force, weigh scales and battery fuel gauges, factory automation equipment and many more like this. This sensor can be purchased from our website, that is controleverything.com. You can download the code from resource tab and after that as a zip file. Also, you can have the code from our GitHub repository, which is Control Everything community. In the end, I would like to clear, if you have any further queries regarding the interfacing and working of the sensor, you can reach us on controleverything.com and you can also post comments on our community page. For articles and blogs on various sensors like this, you can look us on instructable.com and you can subscribe our YouTube channel for more video tutorials like this. In the end, I hope you enjoyed the video and have a good day.